What's a bit of a paradox is that firms do better if they coordinate with each other to, let's think about Bertrand firms setting prices, if they coordinate to choose to price at the monopoly level. If that's the case, they each make half the monopoly profits. If they don't coordinate, if they just let competition run wild, they run down their prices all the way to marginal cost and they make zero profits. Half the monopoly profit is a lot better than zero profits, so why don't firms do that? Well, it's better for them if they could both do that, but there's this sort of lack of trust where no firm individually has an incentive to play along. They can do better by sort of undercutting their rivals, okay? And that's sort of built into the logic of the game we just presented. But now let's introduce a new version of the Bertrand competition game called a repeated game. And what happens here is that in every period, firms choose prices, and then they do the same Bertrand stuff that we did before. But the difference is that that's not the end of the game. The next period, they play the same firm again, and they choose prices again, and the same, profits are realized, and then they do it again and again. And they do that. They never know when the end is going to be. Okay, every period there's maybe some probability that the game is over, that one of the firms goes bankrupt or the market disappears, but they never know when that's going to be. So from their perspective, it's kind of like it goes on forever. Okay, so let's suppose that it actually does go on forever, and let's think through how that changes the Bertrand competition game. So this is called a, what did I just do? Yeah, this is called a repeated Bertrand game. And the kind that we've done before where it's not repeated is called a one-shot Bertrand competition game. So let's lay out our assumptions again. We're going to have two firms. We're going to have demand is given by Q equals 10 minus P. These firms have constant marginal cost C equal to 2. And it's Bertrand competition, so the lower price gets 100% of demand of Q. If they have the same price, each gets 50%. And so this is so far the same as what we did last time, but now we're going to say firms play. That means they choose prices every period. And let's think of a period as lasting 1 year. So it's sort of like they rethink their prices every year. And now that we have profits that are going to come in this year and next year and the year after that and after that and after that, we have to discount those profits. We have, if we're going to make a strategy and that strategy we do today affects what happens tomorrow, then we have to find a way to value those future profits. And so we're going to use the standard discounting that we introduced before. They're going to discount the future with an interest rate of R. And so what does that mean? Well, let's sort of write it out. So, for example, suppose they set the price equal to 6 every period. That's the monopoly price, remember. If they do that, the monopoly profits are equal to 6 minus 2, and they sell 10 minus 6 units, so that's 16. Each firm gets half, so each firm ends up with 8. And so the value of playing a price equal to 6, if both firms do that, so let's say P1 equals P2 equals 6, well, they would get, let's say the value is equal to 8 this period, but then next period we're going to discount it by 1 plus R. Okay, the period after that we get 8, but now that's 2 periods in the future, so we discount that by 1 plus R squared, and so on. The third period is 1 plus R cubed, all the way into the future. Okay, this goes on forever. And so we can write this actually like so, using the summation notation. So this is a sum of terms ranging from 0 to infinity, and each one of those terms is defined like so. 8 divided by 1 plus r raised to the power of t. So when t is equal to 0, 1 plus r raised to the power of anything raised to the power of 0 is 1. So that's 8 divided by 1, or 8, that first term. When t is equal to 1, it's 8 divided by just 1 plus r. That's the second term. 2 is over there and all the way into infinity. Okay, so we can rewrite this. Notice that they all have this constant 8. There's no t on this 8, so we can pull that out. We can like factor it out from each of these terms. And we get this. Okay. Now, let's, there's one more trick that we kind of like to do. We're going to define something called a discount rate, which is just a new term given by the Greek letter beta, kind of like the Greek b, and that's going to be equal to 1 over 1 plus r. Okay, so if we define this new term, it's just going to be easier to write then, and it can also be interpreted in different ways, which will be useful in the future. We can write this a little bit easier like this. So instead of writing 1 over 1 plus r, I'll just write beta to the t, because I've defined beta in this way. Last useful trick is it can be shown that the infinite series of beta raised to the power of t is equal to 1 divided by 1 minus beta. And there's proving that is in one of the future videos. It's not a hard proof, but let's not get derailed proving it right now. So given that we can prove this, and we've said that the value is equal to 8 times this infinite sum, that means that the value is this term here. And since beta is equal to 1 over 1 plus r, we've got sort of the value of playing the Monopoly game every period. Okay, so that's how we can think about the value of colluding. Okay, you would get this. But the argument, this isn't really enough to say they want to collude yet, because at this point, what's different? Why wouldn't every period the rival want to undercut you a little bit? Why wouldn't they want to set their price equal to $5.99 and steal all the profit and earn 16 or something very close to it? To get the real intuition of how a repeated game changes things, we need to talk about what a strategy is in repeated games. So in a repeated game, remember, a strategy is basically what you decide to do, right? It's the price you pick. In a repeated game, a strategy is your action in every possible information set. Okay? So you would think maybe that a strategy in a repeated game is not just what you're going to do, but what you're going to do every period. But what you're going to do in each period, you have to have, your strategy has to sort of have like a bunch of different possibilities inside it. So it's a strategy like saying, I'm going to do this if this happens, I'm going to do that if this happens, I'm going to do this if that happens, right? So what can change is in every period you might end up knowing different information, and that might mean that you choose a different thing. You don't have to specify in advance, like in period 3 I'm going to set my price equal to 5. You can say something instead like, in period 3, if the other guy sets his price at 6, then I'm going to set it at 5. But if he sets it at 4, I'm going to set it at 3 or something like that. So different strategies for different information sets. So in this game, in this repeated game that we've done, what's the information? Well, it equals things like demand, which we know is 10 minus P. It's marginal cost, which we know is C equals 2. Those things don't change. So you really they don't play a big role in it. But another is the history of prices by each player. So the real thing that matters is is how you respond to the history of how the other guy has played. Okay? For example, it will turn out to be very important if the other player has always played half the monopoly value, for example. If the other player has always set their price equal to 6 and allowed you to earn half the monopoly profits, then you may think that they're likely to do that in the future, and so you reciprocate by also setting your price equal to 6. On the other hand, if they have always set their price equal to 2, the marginal cost, you might think that they're likely to do that in the future, and so you might set your price equal to 2. But we can get a little bit more sophisticated than that. So let's define 3 different strategies to sort of show how strategies work in these repeated game versions. All right, strategy 1 is always set your price equal to 6. Is this a strategy? Yes, because it specifies what you should do in all information sets. In this case, you don't really use the information sets. Whatever the information set is, you just set your price equal to 2. Strategy number 2, always set your price equal to 2. Again, this works as a strategy in a repeated game because it says what you should do in every information set. Are these Nash equilibria? We'll talk about that in a minute, but let's define one more strategy that's more sophisticated. It switches between these 2 strategies. It says initially, so in the first period, set P equal to 6. Keep P equals 6 if the other firm has always played P equals 6. Otherwise, set your price equal to 2. This strategy is known as a Grimm trigger strategy for reasons that I'll discuss in a minute. So strategy 1 is basically says always set your price equal to the monopoly level. Strategy 2 says always set your price equal to marginal cost. And strategy 3 switches. It says start at the monopoly level and stay there as long as the other firm sets their price at the monopoly level. But if they ever deviate, if they ever choose to do anything other than monopoly level, switch to pricing equal to marginal cost forever after. Okay? So it's a triggered response, and it's called a Grimm trigger because when you set your price equal to marginal cost, you sacrifice all future profits and you screw the opponent. They can never get profits either. You like lay down the hammer in the most unforgiving way possible in the context of this game. Nobody's ever going to profit again because this other person deviated. So how does this last strategy work? Well, suppose you know that the other player is playing this strategy. Then you think to yourself, all right, if I play 6, I get half the monopoly profits. If I undercut him a little bit, if I choose 5.99, I steal all his profits for this period, but then he's going to do this Grimm trigger next strategy and set his price equal to 2 forever, and I'll never get profits again. So maybe it's not worth it for me to do it. And it turns out that this is going to be kind of the key insight for how collusion can be sustained in repeated games. We'll talk about which of these strategies is a Nash equilibrium in the next video.